Okay, good morning. Listen, uh, today's portion, solar cell. The last concept of your electronics. Transistors are not present. Okay, it has been removed from the syllabus. Okay, in the beginning, we had transistors, but now transistors are removed from the syllabus. Therefore, electronics portion is very easy for you now. Now, solar cell. Solar cell, first one mark question. I told you already, here we are asking either for 1 mark or maybe maximum for 2 marks that we are asking, not more than this. Usually we prefer to ask for 1 mark question only. Okay. Maximum we can ask for 2 marks question. First 1 mark question. Write the circuit symbol for solar cell. Write the circuit symbol for solar cell. Circuit symbol, how we are going to represent. So this is the circuit symbol. See here, cell only. The cell is representing like this. This is a cell, ordinary cell. Solar cell, we are writing like this. Put a round mark, representing it is a cell. Extend this terminals. It is a cell only, still it is a cell only. Light energy we are supposed to make use of here. Okay, like this. This is light. E is equal to h nu. This is the light energy. Light energy, if it is incidenting solar cell, it will work. If there is no light energy, solar cell, it will not work. So this is the circuit symbol. If you are writing this much, you will get 1 mark. Write the circuit symbol for solar cell. Cell operated with the h nu, means light energy. As the light energy is incidenting here, then solar cell, it will starts to work. That is representing like this. It is a solar cell, circuit symbol for solar cell. Okay. This carries 1 mark. Next question, solar cell, how it works? What is the principle adopted in the case of solar cell? So here we are converting light energy in the form of electrical energy. Light energy we are supposed to convert in the form of electrical energy. To convert the light energy in the form of electrical energy, we require a cell here. Now that cell is called by the name solar cell. It is a solar cell. Solar cell can be used. Monisha is asking, solar cell, is it possible to use it in LED? You can use. Solar cell is a cell which produces a current and voltage. Okay, LED is a particular device which is utilizing the current and the voltage. I hope you understood. It is a cell. But here, if you are keeping this one under the shadow region, it will not work because no light energy is incidenting, and hence the solar cell, it will not work. Okay, most of the occasion now, don't forget some engineering students, they have made a car which is operated with the solar cell. Okay, the car top surface is containing the solar cell panels, and the car inside that one, it is having the battery. The battery is charged by the solar cell, and that battery is working, and hence the car wheels starts to move here, mechanical energy converting, and it is once it is moving here now, we can start our cars to move it here. Okay, EV cars are available now. Now future cars are said to be the EV cars only, electric vehicles, EV, electric vehicles, like your two-wheelers, electric vehicles are there now. Like that, the cars are also coming with electrical vehicles. Electrical vehicles, only one thing is said to be existing. The battery system is said to be existing. That battery must be recharged. But I am talking about here, it is a solar cell, where at your home also, of course, in future days, not necessary to waste our money on KB, current and other things. Okay, if we are operating with the solar cell at the top surface of the flooring, maybe it is said to be the the top surface where the open space is there. If you are keeping the solar panels, converting the light energy in the form of electrical energy inside the home, that we are converting that, or we are storing the electrical energy in the form of battery. Whenever it is required, we can use it. Okay, solar panels. Gujarat, especially Gujarat, okay, around about, I think it's so, more than about 8 kilometer the distance over a channel, okay, water is flowing here. Over that one, it has been covered with solar panels, and around about 33 villages, they have been supplied the solar energy, electrical energy continuously they are supplying. But only the one fact is said to be existing here, that is solar cell, no, it is not available with a very cheaper rate. Okay, for example, if I'm paying for the KEB every month 1,000 rupees as an electricity bill, if you want to avoid that electricity bill of 1,000 rupees, we had to go for the solar cell. That solar cell may be cost around about 2.5 lakhs or 3 lakhs rupees. Then paying 1,000 rupees per month is easy, but investing 3 lakhs rupees at a stretch, not so easy. If the solar cell panels are reducing their prices, manufacturing, it will become easy. Then if it is reducing the sale price, then all of us, we can use it. Then not necessary to have the electricity, hydroelectric project or something else, electricity, whatever we are buying from the Karnataka Electricity Board. Okay, we can stop and we can use our own solar cells. And if your solar cells are producing the more current, then we can give the current to the KEB. We can give the current to the KEB. Okay, that facility is also there, of course. Okay, solar energy and other things, it is a huge concept now. Yes, right. Anyhow, it is only a small concept that we had to cover here now, not in an elaborate way here, because solar energy, that itself is a branch of physics nowadays. Okay, solar cell symbol is this. Light energy converts in the form of electrical energy using a solar cell. Solar cell converts the light energy in the form of electrical energy. Light energy may be artificial light or maybe it is sunlight. Usually we prefer to go for sunlight because India is a tropical country. Around about in 1 year, around about 360 days, we are going to get the light energy continuously. That 5 days also we are getting the light energy. Okay, maybe rainy season you may not get it due to cyclone effect or something else. Remaining 5 days that here and there that we are going to miss it. Except that one light energy, huge amount we are getting here now. That can be converted in the form of electrical energy. Then the light energy we can convert in the form of an electrical energy, which is a useful energy for all of us. Then that cell is called by the name of the solar cell. Solar cell, usually we are using even in the case of what is that spacecrafts. Okay, if you want to move out of the earth and orbiting around the earth, not so easy to get the electrical energy. Then the light energy coming out from the sun, converting in the form of electrical energy. Okay, solar panels are said to be existing. The scientists first they are going to do that one only. Solar panels, it is artificial satellites. First the solar panels must be get open. If it is get open, then only they will start to work. Other concepts, because we want to get the electrical energy to do the work. That can be done by using the solar cells. Okay, coming to the concept. Light energy converts in the form of electrical energy by using a cell. That name is called by the name of the solar cell. Then solar cell construction and working here. The one is a construction, the other one is working. How we are going to construct? It is a PN junction only. Solar cell means it is a PN junction made up of either silicon or gallium arsenide. This PN junction, either it is made up of silicon, or it is made up of gallium arsenide. Okay. This silicon or gallium arsenide PN junction first we have to make. For example, let us consider this is the P variety, above that one. Below that one, there is an N variety. This is P variety, is present here. Below this, there is an N variety is present here. This is N variety and this is P variety. Okay, below this, we are coating some copper plate or something as an electrode that we are going to coat. It is a copper plate. Above this one, we are going to put some finger electrodes. I said finger electrodes, just like our finger. Because one finger to another finger, there is a gap is there here. Through that gap, light energy can pass and it can enter here. I will show it like this. I can show it here only, hoping that you can understand. This is P variety, this is N variety, this is electrode. Which is that electrode? Copper material. This is copper material. This is P variety. This is N variety. This is a PN junction. Here there is a PN junction. P and N. P, N, there is a junction. Above the PN junction, P variety, we are keeping electrode here. The electrode in the shape of a finger. It is a finger electrode. One finger to another finger, there is a gap here. Through that gap, light energy can pass through. That finger electrode, it has been attached to the copper plate. That copper plate is connected to the copper wire. That copper wire we are taking outside here. Again, carefully see here. There is PN junction. P variety is there. N variety is there. N variety, above that one, P variety is present. Below N variety, we are keeping a copper plate as an acting as an electrode. Above P plate, we are keeping finger electrodes. We are keeping the finger electrodes. Just like our finger, the electrodes are present. One finger electrode to another one here, there is a gap is present. Gap must be there. If it is completely closed here, light energy cannot be passed through here. If it is completely closed here with a copper plate, light cannot pass through. For that purpose, we are keeping the finger electrode like this. Now here there is a copper plate connected to the copper plate here and connected to the copper wire. Now, as the light energy is incidenting here on the P, then passes through the P, incidenting on the PN junction here. Once it is incidenting on the PN junction, okay. So this is the PN junction. Once it is incidenting on the PN junction, this is PN junction. This is charge depletion region. P and N is present here like this. Now, as the light energy is incidenting here, this is a light energy. Of a suitable light energy, of course, E is equal to h nu. According to quantum mechanics, E is equal to h nu, Planck's quantum theory. E is the energy, h is the Planck's constant, nu is the frequency of light energy. So, as the light energy incidenting on the PN junction here, now as the light energy is incidenting here more number of covalent bonds are breaking up. It produces more number of electron hole pairs. Electrons are moving like this. Like this. Electrons starts to move here. Electrons move. Here holes, whatever it is said to be existing, the holes are moving like this. Again, I can repeat, as the light energy incidenting at the PN junction, covalent bonds are breaking up here. Due to that action here, more number of covalent bonds, if it is breaking up, electron hole pairs are more and more it is generating. As the electron hole pairs are producing here, electrons are moving towards N variety, holes are moving towards P variety. As the holes are moving here now, holes are having the positive charge. Current, it starts to flow like this. This is the current, it starts to flow like this. This is the current. Current due to holes. Current due to holes. Light energy is incidenting. Holes are moving like this. Due to that, holes are moving here now. Current is passing like this. Current due to the holes. Electrons are moving like this. Don't forget, if the electrons are moving in one direction, then the current is passing in the opposite direction. Don't forget about this concept. Next, I will start electricity or electrostatics. Electrostatics I will start better, or electricity I will start, or 1 or 2 chapters of electricity first I will start, then I will take up the electrostatics. Let us see that depending upon the situation from tomorrow onwards. This is P, this is N. According to electricity concept, if the electrons are moving in one direction, then the current is passing in the opposite direction. That is called by the name the conventional direction of current. Conventionally. Okay, our ancestors, they made a mistake and we are following that. But actually electrons are, if they are moving in one direction, that is a current. But our ancestors, they have treated that one in the opposite direction. We are following that. Electrons are moving like this. Therefore, the current is passing in the opposite direction. Here, electrons are moving like this. In the opposite direction, current is passing like this. In the opposite direction, electrons are moving like this. In the opposite direction, I will show the current here now, that current due to electrons. We are connecting here a resistor, we are connecting. Now, this current due to electrons are moving like this. Current due to electrons are flowing like this. Due to that one, current is flowing like this. Current due to the holes are also moving in the same direction. But electrons are moving in the opposite direction. Holes are moving in the opposite direction. Electric current due to electrons, electric current due to the holes, both are operating in the same direction. Therefore, here, there is a large current is flowing here. That current into resistance, you are getting a voltage here. According to Ohm's law, V is equal to I into R. Here there is a voltage. Across this one, there is a voltage. That voltage is equal to V is equal to I into R. Therefore, voltage is producing here. There is a production of voltage due to this light energy. For example, this light energy is cut off. If I'm stopping this light energy is stopped here. Now, electron-hole pair is not producing. Electrons are not moving here. Electric current due to that one is equal to 0. Holes are not moving here. This whole current is equal to 0. This current is equal to 0. This voltage is equal to 0. As the more intensity is present here, as the intensity of the light energy is more and more and more, as the intensity is more here, more holes and electrons are producing, more current is passing, more voltage is producing. Therefore, this particular cell can also be used as an intensity measurement meters. Light intensity measurement meter, there also we are using. Solar cells, voltage cells. This is the production of voltage here. Okay, since there is a production of voltage, I can say solar cell producing a voltage. A solar cell, if it is producing a voltage, that voltage we can use it wherever it is required. But this voltage is a very small voltage here. If you are using only one particular solar cell. Like this solar cell, we are using so many number of solar cells in series and parallel. Then we are going to have a panel. Huge panels you are going to get. One panel is containing so many number of solar cells. All the solar cells, they are all connected in series and parallel. Therefore, we are going to get a huge current and the voltage. That current and the voltage, we can use it for our day-to-day life. Wherever if you want to use it, you can use it. Solar cell we are using in so many applications, so many ways that we are using nowadays especially. Okay. Your watches, some of the watches are operated with the solar cell. Some of your calculators are operated with the solar cell, and some of the street lights, not all the street lights, in some particular street lights in park or somewhere else, they have put the solar panel. Below that one tube light or something, a LED bulb, it has been present here. As soon as the evening is set to be happening, as the light energy is stopped here now, automatically it is going to get switched on. That is a solar cell, operated with the solar cell. Okay, coming back to the concept. Solar cell, circuit symbol, we are asking for 1 mark. Solar cell, working condition or principle, light energy, it converts in the form of electrical energy. Solar cell is basically a PN junction. The PN junction, either it is made up of silicon or it is made up of gallium arsenide. So there is a PN junction here. So there is a PN junction here, P and N. Below N, there exists a copper plate here acting as an electrode. Above P here, there are so many number of finger electrodes. Once the light energy is incidenting here like this, at the PN junction, electron hole pair is going to get produced. As the intensity is more here, electron hole pair number is said to be more. Intensity is less, electron hole pair number is also less. As the light energy is incidenting at the PN junction, covalent bonds are breaking up, more number of electron hole pair is producing. Holes are moving towards the P variety, electrons are moved towards the N variety. Due to this one, electric current due to the electrons and electric current due to the holes, they are operating along the same direction here. Holes are acting like this, therefore hole current is present. Electrons are acting like this, electron current is present here. Then added up here as a total current here. The current into resistance is the voltage. Therefore, you are going to get the voltage across this resistor. This voltage, we can use it for our convenience. Where if you want to use this voltage, we can use that voltage. This is the concept. Okay, yes. Solar cell uses also we can ask. I told you already where we are using solar cell. Nowadays we are using in the spacecrafts, artificial satellites we are using. Okay, solar power wherever we are using in the form of calculators or maybe the wristwatches. Okay, some occasions we are using even in the case of solar water heaters. It is different, completely different. Solar water heater is completely different, where the IR energy, infrared radiations that we are using. This is completely a different concept. Light energy is incidenting and we are getting a voltage here. Okay, solar water heaters where we are not getting the voltage, where we are converting the light heat energy, sunlight heat energy, we are converting in the form of hot water, nothing else. Okay, this is a solar cell, that is solar water heater, that is completely different. Don't get confused with that and this. Okay, go through all the things. Today I have covered all the concept regarding whatever it is present in your electronic syllabus. Very easy, 10 to 12 marks easily you can secure in all these concepts.